Hello everybody, in this video we'll be learning how to graph a function rule. First of all, the set of all solutions of a function form its graph. When we're making our graph, the points in the graph should make sense. I'll talk more about that later. We need to choose appropriate intervals for the graph, which I will also talk about later. The intervals should be constant, and we'll also talk about a continuous graph versus a discrete graph. So let's try some out. Here we're going to graph the function y equals negative 2x plus 1. In this case, I'm choosing to have all four coordinates to see what happens when x values are negative and when x values are positive. So I'm just going to get some random numbers here. So I'm going to choose the number negative 2. I always like to try some negative numbers, some positive numbers, and see how that affects the graph. So in this case we have all of these are going to be negative 2 times something plus 1. So I'll just put that in blue here. Negative 2 plus 1, negative 2 plus 1. And then the red values are the values I chose as things to put in for x. You don't have to choose these values, but again, it's nice to choose low values like 2s and 1s and 0s because the calculations will be easier. It's also good to choose positive and negative numbers to see how negativity might affect the look of the graph. Alright, so we have negative 2 times negative 2 is 4, plus 1 equals 5. Negative 2 times negative 1, that's 2 plus 1 is 3. 0 plus 1 is 1. Negative 2 plus 1 is negative 1. And negative 4 plus 1 is negative 3. Now I'm going to write that as coordinate pairs here. So we have negative 2 comma 5, negative 1 comma 3, 0 comma 1, 1 comma negative 1, and 2 comma negative 3. Now I'm going to use these coordinate pairs to graph over here. I'm going to use an interval of just 1 in this case, so each grid line is worth 1. So I'll put a 2 here to show that that's happening. The reason I'm not doing 1 is because that kind of scrunches everything together. So I want it to be somewhat neat if possible. So graphing now, negative 2 comma 5 is going to be 1, 2, 3, 4, 5 right here. Negative 1 comma 3 is right here. 0, 1, 1 negative 1, and 2 negative 3. So it looks to me like we have a linear function here. And whoops, I'll just kind of try to draw a line through the graph. That's not perfect, but you get the idea. Make sure when you're graphing, if it goes on forever, show that that is the case by putting arrows on the sides here. These arrows indicate that I could choose x values of 3 or 5 or 10 or a million and negative a million, and then I could still get an answer. Obviously we can't put all that on the graph, so that's why we use the arrow. Alright, next problem. Not that one, this one. Okay, let's assume that W equals the weight of a concrete mixer truck and that C equals the cubic feet of the concrete. In this case, the truck will hold a maximum of 200 cubic feet of concrete. And we have an equation here that the weight of the truck is going to equal 146 times the number of cubic feet plus 30,000. And then we're going to graph the weight of this concrete mixer truck. So let's say that there was 0 cubic feet of concrete. Then what happens? We will have, I'm going to do it in the same color just for time here, 146 times 0 plus 30,000 is going to equal 30,000. And so our coordinate pair is 0 comma 30,000. And we can graph it down here. When there's 0 cubic feet of concrete, the truck weighs 30,000 pounds. Notice in this case, instead of writing 10,000, 20,000, 30,000, I put 10, 20, 30, 40, 50, 60, and just wrote thousands over here to indicate that each of these is actually thousands, so 10,000, 20,000. Also note that my intervals on this graph, I chose on the x-axis to do each grid line represents 10 cubic feet, and the reason I did that is because the maximum is 200, so there's no reason to go any higher than that, so I wanted to spread it out. Then over here I wanted to show every 10,000 because I figured out that 200 times 146 plus 30,000 is going to be 59,200. So I don't need to go over 60,000, but I couldn't really think of a nice way to space these out a little more. 3 doesn't really make sense for 10,000 because everything would be like 3,333. So I just made every line 5,000. All right, so 0, 30,000 goes there. 50, we'll try plugging in 50 here. And it's 146 times 50 plus 30,000. And that is going to equal 37,300. You can use a calculator for that. So 50, 37,300. It's kind of awkward to have the comma separating the numbers and then also a comma for 37,300. But can't think of a way around that right now. So 50 goes to 37,300, which is about right there. Should be on the line though. There we go. Then we go to 100. Equals 146 times 100 plus 30,000, which is going to be 44,600. So we get 100, comma, 44,600, and that would be 100, and then up to 44.6, which is about 45. Okay, and then I'll spare you all the other calculations. It's just going to be 150, and this is going to be 51,900. Whoops. 150, 51,900, which is going to be about there. And then 200 is going to be 59,200, which is very close to 60,000. As you can see, this is also a linear equation, like that. All right, let's try another. Let's say we want to graph the weight of cheese in ounces based on the amount of gallons of milk that we use to make the cheese. And here is an equation here. The weight is going to equal 16 times the milk, the gallons of milk. And I've set up a chart here. So if, notice the graph is only positive values because we wouldn't have a negative amount of milk and we wouldn't have a negative weight of cheese. So only positive values. Also note my intervals here. They're the same. Every grid line is 5 ounces. And then over here, every 4 grid lines, I put 1 gallon just to space it out a little bit. So if I use 0 gallons of milk, I obviously get no cheese. If I use 1 gallon, I get 16 ounces. It's about right there. 2 gallons, 32. About right there. 3 gallons, 48. Close to 50. 4 gallons, 64. Pretty close to 65. Okay. As you can see, this is also a linear. Whoop, pretend that's straight. This is a linear equation. All right. Now we're going to do this one. So imagine that we're talking about cheese again. So the amount of money you make is going to be based on the number of cheese wheels you sell. And here's an equation. Amount of money equals 9 times cheese wheels. Again, I've done only positive values because you won't sell negative things and you won't have negative money in this case. Although it is possible to have the concept of negative money in a graph. So again, my intervals are such that I spaced it out as much as I could using the whole graph. The intervals are the same. Every 4 grid lines is 10. So each grid line is about 2.5 dollars at this point. So if we sell 0 cheese wheels, we make $0. If we sell 1, we make $9, so that's about up here. And 2, we make 18, so that is right above there. And 3, we make 27, so that should be, let's see, 25, which is pretty close to there. And 4, we make 36, which is just above that. Okay, now this is going to be different than the other graphs because in this case we're not selling half of a cheese wheel. We're only selling full cheese wheels. So rather than showing the graph as continuous, it's a straight line where we could have half gallons and 2.5 gallons, 2 1/3 gallons. This is called a discrete graph where we're only graphing specific points, okay, because we're not going to sell a half a cheese wheel in this case. Alright, I'm going to do 2 more examples. In this case, we're going to do an absolute value graph. I'm choosing negative values for x because, as we know, absolute value has to do with positive and negative numbers. So I want to see what the graph looks like with negative numbers. I'm choosing fairly small values just to make the calculation simple and to see if I get an accurate picture here. So if I plug in -3, I get +3 minus 4 is -1. If I plug in -2, I get 2 minus 4 is -2. 1 minus 4 is -3. 0 minus 4 is -4. Again, 1 minus 4 is -3. 2 minus 4, 3 minus 4. Let's graph it. So these are the ordered pairs, right? So we have -3, -1. That's here. -2, -2. It's here. -1, -3. 0, -4, 1, -3, 2, -2, 3, -1. And let's see, I'm curious because I see that it's going to be a straight line here. I'm curious what happens when it crosses the x-axis. Is it going to continue to keep going in both directions? So let's pick another number like 2, 3, 4, 5. So if I chose 5, 5 minus 4 is 1. So 2, 3, 4, 5, 1. So it actually does continue to go like so. And so that goes on forever. And the same thing is going to be true here. You can check it for yourself. So the graph of an absolute value here looks like a V. All right, and one last one. This is the graph of a squared variable. And let's see what happens. I chose, again, positive and negative numbers because when you square a negative number, it becomes positive. So I thought that might be important. So if we plug in -2, -2 squared is 4 plus 1 is 5. -1 squared is 1 plus 1 is 2. 0 plus 1 is 1. 1 plus 1 is 2. And then 2 squared, which is 4 plus 1 is 5. So -2, 5, which is 1, 2, 3, 4, 5. And we have -1, 2, and then we have 0, 1, and 1, 2, and then 2, 5. What you'll notice is that it is not the same, it won't rise the same amount in between each number. So, for instance, as I went over 1 here, it went up 1. Then I went over 1 from here, and it went up 3. So it's not a straight line, it's definitely a curve that looks kind of like a U. Alright, and that's going to be it for the video. Thanks for watching.